As the last module for simulation in Omnet++, let's look at the classical problem of comparing switching versus routing. And if you want to simulate that, what all parameters we should be concerned with, and how can we best do the comparison. First, we need to convince ourselves, why should we compare? After all, routing and switching are totally different ball games. Routing is basically an inter-network phenomenon. Routing process runs before forwarding takes place between the routers, each router connected to a different network. So it is basically a pre-forwarding activity. Switching is only confined to a single LAN segment, and as we know, switching is primarily concerned with looking at the destination MAC address and simply forwarding the frame. Apparently, there is no need for comparison. But if you look at it, switching is performed by a switch and routing is performed by a router. These two devices, they both are deployed within the LAN and onto the internet. So a basic comparison that comes to our mind is to look for router versus switch comparison. Router is actually performing the routing and forwarding process, whereas switch is only doing MAC based port learning table buildup and then forwarding on the basis of incoming destination MAC address. Apparently, these two are doing quite unique jobs. But what they compare and have in common is the behavior they both have towards the destination type of address. For example, if it is unicast or if it is broadcast. If it is unicast, it means that the router is going to keep it within the same domain, so is the LAN. But if it is broadcast, the router is still going to keep it in the same subnet, but the switch is going to send it beyond the LAN boundaries. The basis of comparison, which is based on various parameters, has to include the costs that are associated with real-world deployment. For instance, are you looking at a 10 node, 50 node, 100 node, or 10,000 node system? If that's the case, then would it be wise to deploy all routers? Because the routers have limited ports. Or all switches? Because the switches do not have separate broadcast domains. Or are you going to have a mix of two? Similarly, what kind of traffic isolation is required? Is it strict? Is it not required at all? Or it's flexible? Similarly, routing is a premeditated activity and then forwarding is done on the fly. So the speed is an issue in routing because it is a two-step process, whereas for a switch, it works very fast, but it makes errors also because for all the destination MAC addresses that it has not learned, it will forward the packets as such. So speed is not an issue for a switch, an issue for a router, but switch has its limitations in terms of accuracy, whereas a router never makes errors. And lastly, the complexity. Switch is mainly based on high-speed chipset, whereas router involves an operating system as well. So complexity increases with layer 3 device. The parameters that come naturally as a consequence to these considerations are, what are we trying to look at? For instance, are we interested in determining the overall length of the output queues, or what distribution these output queues follow? What is the relationship of these output queues with respect to long run simulations? The number of packets which are generated by hosts if the traffic is frequent, infrequent, interactive, sporadic, or it is highly aggressive. What is the typical packet size and how do these packet size vary? Is it a single hop network or it's a multi-hop network? And lastly, what is the overall end-to-end delay? Do we have some bounds for voice, video, or is it simply elastic traffic? The typical use case, which is given in INET examples, is the router or a switch package. Here we have, it's a 4-host, 2-device system. Here, for the sake of convenience, just the routers are shown, but then these routers could be replaced by switches as well. You can run the simulation using all routers, then all switches, then you can extend the topology and the routers and the switches could be co-created to see a more balanced simulation run.